Hello and welcome to the last chapter in differential equations, that is chapter 8. And what chapter 8 is basically going to be a way of solving differential equations using matrix algebra. And so we're going to use matrices to help us find solutions to differential equations. So the first part of chapter 8 is just going to be some refresher in what matrix algebra is. And that's going to be all for this week's session. Next week, we're going to go dive a little bit more into how to solve differential equations using matrix operations, and then that will be the end of differential equations. So basically what a matrix is a rectangular array of numbers made up of rows and columns. The size of the matrix is its rows by columns. So make sure that you remember that for matrix algebra, it's rows by columns. And that's easy to always get mixed up in how to actually name your matrix. Some people don't confuse that, okay, columns come first. No, it's rows by columns. A general matrix A of size m by n has the form, and so here's just what a matrix looks like. Now, a square matrix is a matrix where the number of rows and the number of columns equal each other. So when this is the case, we say that the matrix is a square matrix of order n. And then here are some examples. Here's one of a 2 by 2, and here's a square matrix of a 3 by 3. Now, when we do addition and subtraction with matrices, we can only add or subtract matrices that are of the same size. So we can't do a 2 by 3, minus a 3 by 2. That's not going to work because it has to, when we do addition and subtraction, they have to have corresponding components. So for example 1 here, we're going to add matrix A with matrix B, and because they're both 2 by 3 matrices, we can go ahead and add those. And so when we add them, we are adding to the corresponding parts. So this is the first element, and we in the row and the column, so we call this element 1, 1. The first element in the row, the first element in the column, and then we do it the same one. The first element in the row, the first element in the column. And since we're doing subtraction, we're going to do A minus B. We just do 2 minus 2. Then it's going to be 1 minus negative 3, 1 minus 4, negative 1 minus negative 3, negative 1 minus 1, 4 minus negative 2. And so our solution is going to be 0, 4, negative 3 for the first row. And the second row is 2, negative 2, 6. So pretty much fairly easy. When we talk about scalar multiplication, what we're doing is we're scaling our matrix by some factor. And so we're going to multiply our matrix C by whatever that number is. So that's why it's called scalar multiplication. Every element is going to be scaled by whatever factors on the outside. So here we have matrix A, which is a square matrix, 2 by 2. And what we want to do is we want to multiply every element in matrix A by 3. So it's negative 2 times 3. 3 times 3, 1 times 3, and 2 times 3. So every element's multiplied by 3, and so our resulting is a square matrix, negative 6, 9, 3, 6. Notice that when we do scalar multiplication, the matrix does not change in size. It stays whatever size it was originally. Just all the numbers are now either increased or decreased depending upon the element or the scale factor.